Two and a Half Admins, episode 19. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And let's start with some news of Google's outage. There was a major Google outage, which a lot of people noticed, but then it got real when the Gmail outage happened a couple of days later, when people were sending emails to people and getting a message back saying that this inbox doesn't exist.
Yeah, that's a big no-no in the email world. Because the worst part about getting a hard bounce is that it sends an error back to the person, and it means that nothing ever gets retried, right? If that was a permanent failure, that account doesn't exist, we're not going to try again in a couple hours. So you sent emails and people never got them. And worse is if, there were emails that were sent to you that you didn't get, and you will never know that they were sent. Google didn't have a way to solve it. And we saw there's a couple of threads on Hacker News and so on. Companies that do email delivery stuff are like, yeah, well, our system automatically unsubscribes people when we get back. The email doesn't exist.
Yeah, that's the issue. The big issue is not so much that it was an SMTP, 5 series instead of 4 series, permanent instead of temporary. You get those all the time, and in a way, those are actually kind of better because at least the person who sent the mail knows it didn't get to you. Whereas if you send an email and it gets SMTP forward on the other end, you don't know anything about it. Like your mail server just decides to wait a random amount of time and try again. If it gets another one, it'll wait a longer random amount of time. And with most default configuration mail systems, you can actually end up with a mail in limbo for like a week and you have no idea it hasn't been delivered. And you're like, why isn't this jerk replying to me? And it's because they haven't seen your message. With an SMTP5 series, at least you know immediately because your own mail server will instantly tell you this bounced, it did not go through, so you know you need to get to that person some other way. So that wasn't the big problem. The big problem was that the specific SMTP5 error actually said user does not exist. So that's the thing that says, it's not just that something was down and something didn't work, that guy ain't here anymore. And keep in mind, this is not just affecting personal Gmail accounts, which is bad enough. It's affecting, a huge swath of company, hosted G Suite or whatever they're calling it this week. So you get one of those from somebody that you're trying to email, at a company that you're working with, and you're like, oh, crap, Joe got fired.
Yeah, my sales rep doesn't work there anymore. I should go reach out to somebody else.
Yeah.
And, if you're the commission sales guy, that could be a big dent to you.
But this was an OAuth problem at its root, right?
Yeah, the OAuth service stopped working, and Google does not have a vaguely normal email delivery platform underneath Gmail. It's all Google fancy stuff under the hood, and with OAuth down, that's why you got this user does not exist because the OAuth service is just like I don't know who that is because everything's broken, and the root cause of that underneath it was Again, everything is special and fancy and funky and automated at Google, and they had a protocol that would automatically start lowering quota on services that weren't used very often. And there was a bug that convinced, this Google service that lowers disk quota on things that the OAuth service just wasn't getting used. So its disk quota keeps shrinking and shrinking, and eventually it can't write new data anymore. So as this happens, the data that OAuth is able to return to other services starts becoming stale because it hasn't been able to write any new tokens for users. So now other services start rejecting these stale tokens, and then eventually you end up with, what the whole world saw, which was giant swaths of users apparently not existing. So the outage didn't actually just affect Gmail. It affected anything that was using Google authentication and OAuth. It's just, Gmail is the thing that really lit a fire under people's butts.
Yeah, but you can imagine this could have led to saying, your favorite YouTube channel doesn't exist anymore. And you'd be like, what happened? And stuff like that. It seems Google doesn't actually have a good way to differentiate between there was an error in trying to look up this in OAuth and specifically, OAuth said this doesn't exist.
Somebody forgot to check for a case there. There's not much doubt about that. Untrapped error is the phrase we're looking for there.
Yeah. Like many of these types of outages, it's not necessarily something someone would have foresaw, but treating every error as the user doesn't exist instead of having, specifically this user doesn't exist, and then any other error should probably be treated as temporary.
Is this just a symptom of the overcomplication and over-automation that Google has to deal with because of its massive scale?
Partly. The fact that, you can get sent an email, like a password reset, and it shows up in your Gmail like almost instantaneously would be pretty hard to do without the level of crazy that they're doing. But at the same time, the thing that was really behind it, the quota thing, sounds like it was Google trying to save some money by being like, hey, we'll just clamp down everybody's quotas unless they're using the space. And it's like, you're Google. You shouldn't be that worried about how much space you... But, they've started adding these quotas on your Google Drive and your Google Photos and stuff. So obviously they've decided that, at the rate that the amount of stuff that's being stored in Google is going up, they're going to run out of space or, they're trying to save money.
Yeah, it does seem weird that was a policy that they applied to the OAuth service. Like, it seems like that should be excluded from anything screwing with it. Like, no, it gets what it needs. We don't shrink the quota on OAuth.
Especially if you're thinking in ZFS terms, OAuth and so on is something you do exactly the opposite of a quota for. You do a reservation saying at least this much space is available for the authentication system and no one else can have that last bit of space. It's basically a quota on everybody that's not OAuth. Nobody else can touch the last X 100 gigabytes of space because the logs or the database or the cache has to work. Otherwise, the internet melts down.
Somebody out there is totally scratching off a space on their 2.5 admin's bingo card because you managed to bring ZFS into this, Alan.
Yes. But it has that concept of, you can put a quota saying, hey, this thing can't use everything, which is a common thing, something I often do for my log directory is say, hey, don't let my logs just clobber everything. But at the same time, if I have a database that says processes payments, I guarantee that database has the last 25 gigs of space on that SSD.
Yeah.
Even if everything is full, the payments keep working because that's how I keep the lights on.
There were a lot of things had to get not thought of for this to happen, basically. We already discussed that. Another thing is that somebody absolutely should have been monitoring the fact that, critical parts of the OAuth surface were out of disk space. Like, holy crap, that should have been, ringing alarm bells, that said exactly what was happening somewhere. But it didn't, which is a little sketchy. And, also, like we were talking about with the OAuth errors, it just kind of defaulting to user not found. Well, that's a symptom of like somebody didn't trap an error. It just fell through to user not found, and that shouldn't have been possible. Had it been coded correctly, there would be some kind of a, we don't know what the crap this is error that it would have fallen through to, not fallen through to user not found.
Yeah, like in a lot of projects, we have what's called coverage testing, where it's like, do we check the case that if this function returns this other value instead of what it normally returns, do we take the right path through the if statement and so on? And it definitely seems like they could have used that here. But yeah, like you were saying, they don't have disk space monitoring. It's like, sure, there's lots of free disk space, but if you're about to hit the quota, that should set off an alarm too, because that meant somebody could have done something about it. But also, it seemed like it took them an awfully long time to fix it because, once the alarm goes up, even if it's just the automated alarm saying, hey, the rate of errors of people trying to email addresses that don't exist is gone up by 20,000% in the last 90 seconds. Hey, get somebody's attention and they can be like, oh, OAuth is returning errors. Oh, I see over here, OAuth is out of space. Increase the quota.
Alan, it's just a shame that they don't have a bunch of machine learning experts on the hand that could, do something to analyze when metrics shoot up 20,000% and be like, hey, maybe this is a problem. A human should look at this. Like, even if it's something not planned for.
You don't need machine learning to do this.
Yeah, well, I mean, just that's the thing that I keep hearing nonstop these days. Like, Everybody's hitting me with the machine learning and, monitoring pitch on like, hey, let it, observe and figure out what normals are. And even if it doesn't know what's wrong, even if you never planned for it, just be like, hey, boss, maybe you want to look at this because this thing just shot up 20,000%. It's never done that before. And obviously they weren't doing that either, which again seems strange given that this is Google.
Yeah. Although I would say that things like just this metric has shot up an unexpected amount would be more like trend analysis, because the machine learning is mostly machines can only learn based on what they've already been, the training material they've been given. So if they can't prepare for a situation they can't expect, it's, one of the biggest problems with trying to use machine learning for driving a car is they'll be able to handle most of it, but as soon as it's something they've never seen before, they won't know what to do.
No, but they can know that they've never seen it before, and they can request an operator, which is exactly what I'm saying should have happened here. It should have just been like, this is freaking weird. I haven't seen this before. Let's make sure the engineers look at this.
But yeah, I don't know if Google generally looks at how many people try to email addresses that don't exist.
I think they might be from now on.
Yeah.
But again, if they were dog fooding their own products, they shouldn't have needed to think about that, to monitor that. They should have just had machine learning ingesting the entire data set, looking for anomalies, and that's an anomaly.
Sure.
That's the whole point of the machine learning part, is you don't have to tell it what anomalies to look for. You can just say, hey, get used to what's normal and alert me when there are anomalies.
Okay, Google, why is Gmail broken?
Yeah, that was an anomaly.
Okay, this episode is sponsored by Linode. Go to linode.com/2.5 to get started with $100 free credit. Whether you're working on a personal project or managing enterprise infrastructure, Linode offers simple, affordable, and accessible cloud computing solutions that allow you to take your project to the next level. Simplify your cloud infrastructure with Linode's Linux virtual machines and develop, deploy, and scale your modern applications faster and more easily. Linode has 11 global data centers and provides 24/7 365 human support with no tiers or handoffs regardless of your plan size. In addition to shared and dedicated compute instances, you can use your $100 credit on S3-compatible object storage, managed Kubernetes, and more. Our website is hosted with Linode, and we couldn't be happier with them. So go to linode.com/2.5 and click the Create Free Account button to get started. That's linode.com/2.5. Let's talk about RISC-V. You wrote about this a couple of weeks ago, Jim, actually a bit more than that, but we didn't quite have time to talk about it last time, so let's talk about it now. This was Micromagic's new CPU, which they claimed was offering reasonable performance with amazing efficiency. I wanted to kind of just get your thoughts generally on RISC-V, but I suppose let's start with this then. You had to try and measure this, and it was not easy, and you got a lot of people telling you that you were wrong in the comments.
Well, I mean, it's the R's comments. You can't get through an article without people telling you're wrong in the R's comments. The hope is that mostly they're wrong about you being wrong.
Okay.
But so anyway, so this particular CPU, usually it's me testing a CPU and running my own tests. And obviously I couldn't do that on this thing. This is a prototype that hasn't really been out of the hands, of these Micromagic people that designed it and built it. And I think it's important to note that, look, this is a prototype. This is not something you're going to buy tomorrow and do a thing. It's more of a proof of concept. And it's a design that, these folks are saying, hey, we'll license this design to you, but more importantly, we'll custom design cores for you. And this is an example of the kind of thing that we can do. And it's RISC-V, it's not ARM. So this was really exciting to me. And I actually learned a bunch of new things about advances in RISC-V. I didn't realize, Alan, Joe, did you know that you can buy a RISC-V development board right now and just install Linux on it and run it?
Yeah.
Yeah. They've been for sale for a while. Things like the Sci-5 and so on.
They're quite expensive, though, for the power that you're going to get out of it.
It depends.
I didn't even realize that it had gotten that far because, it's one of those things for like 15, 20 years now, RISC has just been kind of the GNU herd of processors, Like everybody talks about how amazing it should be in theory, but there hasn't been anything, great to actually do in production with one. It's been about the idea.
There might be a little confusion there. So RISC is a class of processors that includes ARM and all that kind of stuff. RISC-V is not like a derivative of that. It's just what somebody happened to call their RISC processor.
Yeah, but ARM is also, God, this goes into so much neck beardery. I mean, ARM is kind of a RISC design, but there's compromises. RISC-V is a much more pure RISC design, and this is kind of where the whole GNU herdery of it all creeps in, hewing to the original true vision of the RISC architecture, is kind of more of RISC-V's focus, whereas ARM is, more along the lines of, hey, let's get crap done. And, with ARM, you do have fixed order instruction size and execution pipeline, and things are a lot simpler, but it's not as simple as RISC-V is. RISC-V is extremely reduced instruction set. I want to say there's, I think it's like 50 base instructions and a couple of hundred opcodes derived from those, whereas, even ARM, you're in the thousands for opcodes.
Yeah, and it's honestly is the thing that I think is going to be a problem for RISC of trying to get more is that, so if you look at any model of the RISC architecture now, there will be a huge slew of letters after it to enumerate what extensions it supports. Because your base RISC-V, for example, can't do division, I think, even by default. It's, that the base 50 instructions doesn't include that. But there's an extra letter you can put after RISC-V to mean that it does do that. It's basically going to have the ARM problem, but worse, where every CPU is basically its own completely different architecture. And it was interesting to see ARM going away from that with the kind of the ARM server ready concept of, hey, look, there's a bunch of machines and they're basically interchangeable and you can get something like a commodity server. Whereas RISC is going definitely hard the other way of here's at least partly open source ISA, which is one of the other reasons why RISC-V has so much attention compared to ARM, is that a lot of it is BSD licensed.
Yeah.
Where you can pick and choose the features you need to make the smallest, lowest power chip for what you're trying to build. And so for embedded stuff, this could be very, very interesting. But from the side of like trying to support it from the operating system, it gets a bit more difficult. And then, trying to write software that'll run on any RISC-V gets a lot more difficult because suddenly every CPU is its own unique combination of these 50 feature flags.
So is RISC-V more similar to MIPS then than ARM in terms of what it's going to actually be used for?
It's too early to say that, honestly. I think the more interesting question is what the RISC architecture is going to evolve to look like. And I suspect that, all right, so it gets a little weird talking about this stuff. So you have a whole universe of ARM stuff that doesn't necessarily look much like one another, right? You've got the server-based stuff that Alan likes to talk about, and you've got like consumer phone type stuff. And in consumer phones, one of the key things that you look at in that ecosystem is you're not just looking at an ARM CPU. You're looking at an ever-growing cluster of coprocessors in a typical smartphone piece of hardware, right? You've got the CPU, you've got the GPU, you've got a neural processing unit, and they're adding more and more things, on top of this where you say, hey, we're not going to do this complicated function on the CPU at all. We've got a coprocessor for that, and, we'll ship that stuff there. I suspect that's what we're going to be seeing with the RISC-V ecosystem as it evolves. I think it's going to go even further down that route where it says, look, the CPU just does CPU stuff, and it doesn't try to get fancy. x86 was kind of like that back in the day too. You didn't always have a floating point unit in the main processor. It used to be you had, you'd have a 286, CPU, and you'd have a 287, math coprocessor, which was optional. And if you had the 287, then you could run the floating point instructions, but those would get passed off to the math coprocessor, not, run on die with the main CPU itself. They were two completely separate dies. Now, I don't know about entirely separate dies, but I think that approach to having, multiple separate processing units that handle different sets of instructions, I think that's going to be the way that, RISC-V continues to go and goes even more aggressively than ARM has.
Yeah, and I think it'll make sense because you'll have the basic RISC chip that's basically open source and available to everyone, and then companies will license those specialization features, like this one's really good at neural processing or whatever the different things are going to be. Although it reminds me back, 15 plus years ago when AMD was talking about, you're going to have this multi-socket server and you're going to have one CPU chip in there that just for doing XML and one that's just for Java.
Well, but we're already going that way with all kinds of things these days. I mean, once you hit the data center, you've got ASICs for specialized workloads.
Yep.
It's this same concept. You say, hey, this chip does this one thing. It's the Unix philosophy. You do one thing, you do it simple, you do it great. You need a different thing, you do that with a different tool. So we're looking at the Unix philosophy in hardware, basically, and I'm not mad about it.
No.
There's a lot of advantages you get to separating things out that way with, completely separate coprocessors. And I say completely separate, even when it's another cluster on the same die, when it's completely separated out, you start to be able to do funky things like, have the two run at different clock rates, or be able to entirely turn off the neural processing unit, like just powered the hell down when you're not running neural processing, instructions. You can't do that when it's all just kind of, jammed together into one giant complex instruction set system. A lot of the complexity in trying to get clock rates to scale up in, modern complex instruction set processors like Intel's and AMD's is that under the hood, they're kind of not. Like on the inside, they are really kind of a bunch of reduced instruction set tiny pieces, and you're trying to figure out, okay, how can I turn off the power to this one tiny little bit that I'm not using right now, or turn off as much of the power as possible? And it's really weird and difficult because they are tied together. Whereas when they're completely separated out, like they are on a smartphone, you can say, hey, we just don't turn that thing on when we're not using it. And if that doesn't need to be at the same clock rate, we run at a slower clock rate.
And that's why these Apple machines have got ridiculously long battery life, right? Because they can do that. They can turn off the bits they don't need right now.
Yeah, and RISC-V is at least theoretically in a position to, come up behind ARM and do to it what ARM did to, x86. It is even more simplified. And although, again, we're talking about kind of a specialized workload in the sense that that Micromagic CPU, all it's doing is, what they call core pipeline CPU functions, right? And that's why they used a different benchmark. They're not running something that tests a massive complex instruction set or its equivalent in software. And you can do everything on that RISC CPU that you would do on a more complex CPU, but you end up having to emulate those functions in software, and that slows down because, again, you're doing things in software, not in hardware. But, that's with nothing but that core CPU. The idea, again, going forward would be, so, maybe you don't do division on the main processor, but if you need math tasks, you have a math coprocessor.
Yeah, and with RISC having more open source and less licensing nonsense, it might be able to, like you said, just as ARM is starting to ramp up, if RISC can catch up enough, people won't have all made the switch to ARM, and by time RISC is actually maybe the thing that makes more sense to migrate to. It already does for some smaller stuff, like we saw another article we have in the show notes here about Seagate using RISC-V for the microcontrollers and stuff, and I think Western Digital's already been doing that for a couple of years. But RISC, because it has this very extensible ISA and so much open source around it, it means that you could potentially build something that has the same features as the ARM without having to pay as much in licensing. But RISC-V also has the risk that too many of these features are going to end up where you're having to license them, and it kind of takes away some of that value. But I think it'll always be kind of a little push and pull there to make it make sense.
Yeah, it doesn't help that they've licensed it with one of your filthy permissive licenses.
But, they're also a lot simpler to manufacture, a lot simpler and cheaper to manufacture. And because the core CPU design is, completely open source, and a lot of them are free as in beer as well as in speech, and they can be manufactured with, much simpler techniques, and you can have people club together and manufacture multiple chips on the same wafer, when you've got small runs of things that you need to build. We've been in the open source world locked in this scary place for a couple of decades now, where it's like, we want to have this completely free and open source stuff, but we're tied to hardware that's proprietary and increasingly locking things away from us. Basically, we're kind of stuck with the Ken Thompson hack, but, in hardware rather than a compiler. We can tell our x86 processor what to do, but we don't know what else it might be doing in the meantime, and we don't really have any way to look inside it. And because these things are so proprietary and so hideously expensive and difficult to manufacture, we don't really have any other alternatives. I think this RISC-V hardware, now that we're starting to see systems that, actually scale up and provide, decent performance at ridiculous efficiency, we're talking 5 gigahertz clock rates with power consumption in the millowatts. ARM can't even do that. Yes, this is only for CPU core pipeline functions. It's not for a complex instruction set, much less one, emulated in software, but it's still pretty great. And it gives us a sense that, yes, this is a technology that has legs, and because it's so free and open source, and because it's cheap to design and cheap to manufacture, we may be in a position before too much longer where somebody like a Canonical or a Red Hat might literally design their own free and open source hardware to go along with the software.
Okay, this episode is sponsored by Lernard. Sign up at automation.link and use the code admins to upgrade and get 50% off a year's subscription to a new DevOps training site called Lernard. The site covers the entire DevOps stack, starting with the basics of infrastructure as code, and includes almost 8 hours of lessons on Terraform, Ansible, Jenkins, and loads of industry tips along the way. If you're interested in learning DevOps, take advantage of this offer by visiting automation.link and upgrade with 50% off with the code admins. That's automation.link and the code admins. All right, let's do a bit of free consulting then. If you want to send your questions in for Jim and Alan, then you can email show@2.5admins.com. And thank you everyone who's supporting us on Patreon. It's really appreciated. You can find out details of that at 2.5admins.com/support. There's also a PayPal option now, so do check that out. If you support us for $5 or more on Patreon, you can get an advert-free RSS feed. So yeah, check that out. 2.5admins.com/support. So I thought this was going to be the only ZFS mentioned on the show, but you had to crowbar one in earlier, Alan. So well done. But Kyle wrote in and said, I've heard Jim mention a few times that he doesn't run a ZFS on root setup, but does a ZFS on home setup instead. Could you please go into more detail about that? Does that involve multiple drives or one drive that's partitioned? Any guides you could point me to?
You can just do one drive that's partitioned. So usually when I do this kind of thing, I'm doing it on a laptop or a personal workstation, not just a pure server. And the laptop is obviously, the simplest in terms of hardware. There's only going to be one drive. It's going to be an SSD. And I'll partition 100 gigs off the top to use for a root file system. That's just a simple ext4 file system. And then the remainder of the drive will be an unused partition, which I'll feed to ZFS. So you've got a zpool and you've got an ext4 root. Now, when you install the system, you're not telling it about the ZFS at all. As far as it's concerned, it's got a single, 100 gig ext4 and everything's golden. Once the system's installed, you can create your zpool, do a ZFS create, tank/home. Then you, move home to home-dist on your ext4 file system. Then you ZFS set mount point equals home on tank/home, and that's it. Now, your home is there on the zpool, and everything works flawlessly. You don't have to do any, crazy stuff with the OS because it doesn't try to access anything in the home directory until after the zpool is already mounted. So everything just works flawlessly. Obviously, if you had anything going on in your home directory during the setup, you'll want to do a CPA of that, from your home dist that you moved it to into the home, on your pool. But really, that's it. You don't have to worry about anything else after that. There's lots of fun stuff that you can tweak in ZFS specifically to maybe make it, better for a home directory. But really, that's optional. If you don't have the energy to want to deal with that or, the interest, you really don't need to. It'll run perfectly well on defaults.
So defaults in ZFS are designed to work for everybody. They may not be the best, but they will work for everyone. And yeah, it's like for the first couple of years, I did the same thing with even FreeBSD, right? I had the UFS for the operating system, and then I just have a big ZFS mounted somewhere. That's where I put all the media or whatever, when I was hosting video files for my video streaming company or whatever. There are a lot of advantages to having the operating system be on it and being able to use boot environments, but it really depends on a bootloader supporting it, and Grub is just not great at that right now.
Do you think we'll ever get to the point where it makes sense to have the root partition on ZFS then?
Oh, absolutely. We will absolutely get there. It's going to take a bit. FreeBSD is already there. FreeBSD doesn't have the license compatibility problems that the Linux kernel does with, ZFS on Cuddle. That's really the big hitch that's keeping the Linux world from adopting it as thoroughly as BSD has. If Oracle were to do the right thing and, go and, make the BSD or MIT license an option for ZFS, which they could do today if they wanted to, all this would evaporate overnight. I suspect Linus Torvalds would magically suddenly no longer think that ZFS is a pile of garbage. And, we'd see real integration happen in Linux the same way that we did in the BSD world. Without that, we're still going to see it happen slowly enough. I mean, Canonical has been working on it. It's just they're basically the only really large player taking it seriously. So ZFS is great for everybody all the way down to the desktop. I don't want to be without it, now that I have it. But the desktop is kind of like the last place for it to trickle down, on the servers where you really, really want it. And it's already there in Linux as well as BSD. All
right, well, we better get out of here then. Remember, you can email your questions to show@2.5admins.com. You can find me on Twitter @Joe Ressington.
I'm @JRSSNet.
And I'm @Alan Jude.
We'll see you next year.